What bugs did the homeowner find in his home? 10 ants. 10 ants. 10 ants. 10 ants. All right. Let's get to it. GPs, geometric sequences. So this is again a different type of sequence. Last lesson we talked about APs, which were your arithmetic. They've got a common difference. These ones are geometric, and it means that the terms have what we call a common ratio. And you guessed it, ratio is going to be represented by the letter R. Okay, so take a look here. You can see some GPs here. You can see here, how did I get from 2 to 6? I times it by 3, times it by 3, times it by 3. Okay, now that's what we mean by having a common ratio. So that's what that is. Whereas this one here is it's dividing by 2, or in other words, timesing by a half. So 88 to 44 to 22 to 11. Next term would have been 11 divided by 2, and then it would have been 11 over 4, and so on and so forth. And this last one here, you can see that I'm actually alternating, but I'm kind of doubling. So in other words, I'm multiplying by -2. So -1 times -2 gives you +2. Times -2 again will give you -4. Times -2 again will give you +8. And so it alternates. So just be careful whenever you see an alternating pattern. Usually it's because we're using some sort of common ratio that's negative. Okay. Now, very similar to before, we're going to have a couple things that are true for a GP. This is the way that we prove that a series has a GP. Instead of T3 minus T2 for your AP, this is going to be T3 divided by T2. That's how you find a ratio. We're trying to find that the ratio between the third and the second term is the same with the first term and the second and the first. That's how you find your common ratio, which is helpful. Now, finding your nth term, we're also going to have a nice new formula for that. It's going to look a little bit like this. And that there is going to find your 10th, 100th, 67th term. Once you know what A is always representative of your first term. Maybe I should write that down just in case. Just a little recap. That's your first term. N is always your number of terms. And R is your common ratio. Okay. Now, here's a question. Let's say write out the first 4 terms of a geometric progression where A equals to 3 and R equals to -2. So let's just write this out like this. T1, T2, T3. First 4 terms. All right, let's count properly, hey? Will I fit? I'll make it fit. Okay. Now A represents your first term. That's my dog. Puppy. First term is 3, so there you go. And now I have a common ratio of -2. So what's 3 times -2? It'll be, boom, -6. And again, if I times that by another -2, it'll give you my third term, which will be +12. Times that again by -2, -24. Okay, it's going to keep bouncing around like that. Those are my first 4 terms. Okay, didn't need a fancy formula. I just recognized that I multiplied each time by -2. To find the 10th term, though, I could keep going and go for it. But here, it's much easier if I just go T10 is going to, or maybe let's start with my formula. Tn equals to A R n minus 1. And let's do that. So that means our first term, we said for this one was 3. Our common ratio is -2. And I'm going to put that in brackets because it's a negative. And then I'm going to raise it to the power of n minus 1. So in this case, it'll be 10 minus 1. So it's whatever going to 3 times -2 to the 9. Going to be a fairly large number, I think. If you've got a calculator, 3 times -2 in brackets to the power of 9. Bear with me. I got -1536. I know that seems like a big jump, but that's probably going to be your 10th term. I believe that's it. Catch you guys in the next one. All right, bye. Oop.